let's start our snap in control systems. What is a dynamic system?
So the dynamic system have at least one energy storage element is called as the dynamic system.
So every dynamic system is going to have two responses. Can you list those two responses?
Said that a transient response and a steady state response.
Okay, transient response and steady state response. Okay, fine. And then what is the difference between natural response and transient response?
So there is no difference in transient response and natural response actually. The natural response is जब भी हमारा जो सिस्टम होता है वो उसके पैरामीटर्स पे डिपेंड करता है, और ट्रांजिएंट रिस्पांस जो होता है वो भी हमारे ट्रांजिएंट पीरियड पे वर्क करता है. जब भी जो हमारा नेचुरल रिस्पांस होता है वो जब ड्रॉप आउट होता है या वाइप आउट हो जाता है, तब हमारा स्टेडी स्टेट रिस्पांस स्टार्ट होता है. सो आई थिंक देयर इज नो डिफरेंसेस.
Okay.
Transient
What is the
response
difference
and
between the forced response and steady state response?
so the same thing is forced response, and after the transient response, the steady state response, we can analysis. और मतलब जब भी ट्रांजिएंट रिस्पांस हमारा खत्म होता है तो हमारा फोर्स रिस्पांस होता है जो कि इनपुट पे डिपेंड करता है हमारे.
Okay. The stability of a system is decided by which response? Natural response or forced response? Stability of a system.
Sir, it is depend upon the natural response. Natural response टाइम के साथ हमारा खत्म हो जाना चाहिए, तभी हम लोग कहते हैं कि सिस्टम हमारा स्टेबल है. मतलब जैसे जो भी सिस्टम है, जब भी हम लोग इनपुट अप्लाई करते हैं तो जो सिस्टम अपन जो है होता है वो अपना नेचुरल रिस्पांस, ऑब्वियसली नेचुरल रिस्पांस कुछ सिस्टम का होता है, वही उसमें डिस्टरबेंस करता है आउटपुट, जो भी हमारा डिजायर्ड आउटपुट है उसको पाने के लिए. तो जब भी टाइम के साथ मतलब हम तो चाहते हैं कि वो खत्म हो जाए, बट वो एज अ खत्म तो नहीं हो सकता. जो हमारा नेचुरल रिस्पांस होता है तो वो टाइम के साथ कम होता जाता है. तो जहां पर हमारा नेचुरल रिस्पांस टाइम के साथ कम होता जाता है तो मतलब कम होता जाता है, उसी सिस्टम को हम स्टेबल कहते हैं. वो हमारा सिस्टम स्टेबल होता है जहां पर नेचुरल रिस्पांस कम होता है, मतलब टेंस टू जीरो होता है, व्हेन द टी टेंस टू इनफिनाइट.
Okay, fine. Now, what are the disadvantages of RH criteria?
The disadvantage of the,
RH,
sorry sir,
Routh-Hurwitz criteria.
sir, for higher order we can't analysis by the route harvest criteria. और इस रिस्पॉन्स से हम मतलब इस मेथड से हम जो भी पोल है उसके एग्जैक्ट पोजीशन को नहीं पा सकते हैं, और उसकी स्टेबिलिटी को एनालिसिस मतलब कहाँ तक स्टेबल होगा कहाँ तक नहीं होगा ये हम डिसाइड नहीं कर पाते हैं राउट हार्वेस्ट क्राइटेरिया में.
You mean to say we are unable to find relative stability by using RH criteria, right? Relative stability.
Yes sir, we can find relative. Yes sir,
We
हम
can
लोग
find, we can't find
we
relative
can't
stability.
find relative
Okay.
stability.
Take one transfer function. Take one open loop transfer function. GSHS is equal to e power minus 2s by s plus 1.
E power minus 2s
by s plus 1. I want to know whether this system is stable or not. Can you apply RH criteria for this system?
No sir, we can't apply RH criteria on this system.
Okay, fine. So we have steady state error. Steady state error. Can you define what is steady state error?
एक 1 minute sir. steady state error is the difference between our input and desired output.
Okay. What is input? What is desired output? What is the difference between those two?
I mean, when we अगर हम एक स्टेप इनपुट अगर किसी भी सिस्टम को देते हैं, किसी सिस्टम को स्टेप इनपुट देते हैं और वो सिस्टम हमारा अगर डैम्प सिस्टम है, तो अंडर डैम्प सिस्टम है, तो जो भी मतलब at t is equal to t tends to infinite, there is some error in between the input and the output is called as the steady state error.
So you mean to say the difference between input and output is called as steady state error at steady state? Is that?
Yeah, we can say is the steady state error.
Okay. For finding steady state error, what are the inputs we are using?
Sir, wait a minute. Yes, sir.
For finding steady state error, we are using some standard input signals.
Yes, sir. Yes, sir.
What are the standard input signals we are using for finding steady state error?
Sir, step signal.
Any other?
No, sir. No, sir. Step signal because it is the bounded input. RAM signal and the parabolic system is not a bounded input. That's why we can't use for finding the error.
So why we are not using impulse signal for finding steady state error?
Sir, impulse signal not मतलब हमेशा एक ही टाइम पे इम्पल्स सिग्नल हम लोग अप्लाई करते हैं. अगर हम लोग मतलब टी टेंस टू इन्फिनाइट के लिए अगर हम लोग देख रहे हैं सिस्टम के रिस्पॉन्स को या एनालिसिस कर रहे हैं, तो वहां पर हम लोग इम्पल्स सिग्नल नहीं अलाउ कर मतलब अप्लाई कर पाएंगे. वहां पर हमारा सिग्नल सिस्टम ही अप्लाई हो पाएगा.
Okay, fine. Can you define root locus? Root locus.
Sir, we plot root locus uh, uh, for changing the gain k for 0 to infinite, for finding the stability of this for finding the about the stability of the system.
Okay.
Or the response analysis of the system.
When we are changing gain k from 0 to infinity, what is happening in the system?
सर, जब भी हम लोग के की वैल्यू को चेंज करेंगे, तो यहाँ पर जो हमारे रूट्स होते हैं, जो पोल्स होते हैं, वो हमारे चेंज होंगे और उस हिसाब से हम जो भी हमारे सिस्टम का स्टेबिलिटी कंडीशन है कि कब स्टेबल होता है, कब अनस्टेबल होगा, उसको हम लोग एनालिसिस करते हैं.
So when you are changing the value of gain k from 0 to infinity, which pole is changing? Open loop pole or closed loop pole is moving? Which pole is moving from one place to another place? Open loop pole or closed loop pole?
Closed loop pole.
Root locus is the movement of open loop poles or closed loop poles?
Sir,
Okay.
sir,
Fine.
I can't recall it.
Fine. Okay.
I think open loop pole.
What is the
What
rise
is the
time? What is the rise time of a standard first order system?
rise time of a standard first order system?
Yes.
This is the 2.2 into time constant. This is
Okay.
theta.
So if we take RC network as our first order system, what is the rise time formula? RC network. Take series RC network.
Yes, sir.
Then what is the formula for rise time?
RC. V0
What is the time constant of series RC network?
sir RC.
Okay. Then what is the rise time formula for any first order system? What is the rise time formula for standard first order system? You said standard first order system.
Sir, this is 2.2 into time constant.
Okay. Then what is the time constant of series RC network?
This is RC.
Then rise time will be 2.2 RC, no?
Yes, sir.
How to reduce the rise time? How to reduce the rise time?
Reduce the rise time
Of RC network. How to reduce the rise time of RC network?
sir, by reducing or by reducing the parameters, this is R and C.
Which parameters you can change? Only R, only C, or both?
Both. We can change both.
If I reduce the capacitance value, the energy that is stored by the capacitor is going to change. Now, is it recommended to change the value of R, change the value of C?
Sir, we should change the value of R.
Okay.
अगर R अगर चेंज करेंगे तो हमारे जो भी एक्सपोनेंशियल जो भी
Okay.
so it is easy to change.
Yeah. Which parameter is easy to change practically? Resistance or capacitance?
The resistance.
Okay. Fine. Then what is the rise time of a standard second order system?
Rise time. This is pi minus theta upon. Sir,
Okay.
now I can't revise this.
Can you give one practical example for standard second order system? Take one series RLC network. Take a series RLC network.
Yes, sir.
Is it not second order?
Yeah, is it second order?
Okay. Now I need the damping ratio of series RLC network. Damping ratio eta.
Yeah. Wait a minute, so this. So R into L, R into root LC upon 2L. तो अगर L कट जाएंगे तो R into C upon L 2 by 2.
Okay. Fine. Now you have series RLC network with you.
Yes, sir.
I want to know whether that network is stable or unstable. How you are going to find?
Sir, we find the transfer function of this system.
Okay. For finding transfer function, which variable we are taking? Output, which output you are taking? Transfer function means Laplace transform of output by Laplace transform of input. Input is fixed as V of t. Okay. Then which output you are taking in that particular circuit? Voltage across resistor can be taken, voltage across inductor can be taken, voltage across capacitor can be taken, current in the circuit also can be taken as output.
सर किसी भी अगर वोल्टेज को हम लोग आउटपुट एज आउटपुट लेते हैं तो जो हमारा कोई भी आउटपुट ले सकते हैं, स्टेबिलिटी को फाइंड करने के लिए तो कोई भी आउटपुट ले सकते हैं क्योंकि हमें
If you take any output, transfer function will change. Does transfer function will remain same or it is going to change?
Transfer function will change, but if I want to find the stability, the denominator will not change.
Okay, you mean to say the characteristic equation of the system will not change if different outputs are taken, right?
Yes, sir. Characteristic equation will not change.
Will not change. If characteristic equation is not changing, which location is not going to change? Pole's location is not going to change. You mean to say?
Yes.
Okay, fine, ma. Let me give you the feedback, ma. For 80% of the questions, you given answers in proper way, but you need more clarity in some topics. Let me give you the feedback from one question after one. My first question was system, okay, control system, order of a system, okay, just yeah, dynamic system. I asked the first question. The next question was types of responses. We have if you take any dynamic system, we have two responses. One is a natural response, another one is forced response.
Yes.
You should not take the classification of transient and steady state. That is different. This is different. Every system is going to have two responses. One is natural response, another one is forced response. Natural response will depend only on system parameters. Forced response only depends on the input what you are giving.
Yes, sir.
Then I asked, what is the difference between natural response and transient response? You said both are same. Both are not same.
Yes, sir.
Transient response means it is the combination of natural response and forced response in the transient period. Okay. What is the transient period? The transient period is the period in which natural response is also have significance. After transient period, if the system is stable, natural response will not have any significance. Its magnitude will decrease. It will be very negligible after transient period. Okay. I asked the next question was what is the difference between forced response and steady state response? Value wise, both are same, but forced response means the response which is only going to depend on input. It is nothing to do with natural response. Steady state response is the response which is the combination of natural response and forced response, but the natural response value is very, very less. Okay. Then, yeah, I asked you to define steady state error. Steady state error is the difference between desired output and actual output. Desired output and actual output at steady state. That desired output is also called as input. Desired output is also called as input. Okay, that is one question given rank answer. I asked you the definition of root locus. Root locus definition must be given like definition. Okay, it is the path traced by the roots of the characteristic equation when the value of gain k is varied from 0 to infinity. We are tracing the path of the roots when the value of gain k is varied from 0 to infinity. Okay. Then I asked about the time constant of series RC network. Given correct answer tau is equal to RC, and the units are seconds. If we want rise time 2.2 tau, to reduce rise time we have to play only with the resistance. We should not change the capacitance. It is going to affect the energy storage capacity. Okay, and I asked the rise time of second order system. Given correct answer pi minus theta by omega d. I think you did not given correct answer for rise time of second order system, right?
Yes.
Fine. Now, I ask you one example for second order system. Simple, series RLC, parallel RLC will be second order. What does it mean by second order? Which is having two energy storage elements. Those two energy storage elements must be independent.
Sir, actually, I'm thinking about the practical use of the second order system.
I asked one practical example for second order system, series RLC. I asked the damping ratio of series RLC, that is R by 2 into under root of C by L. Resistance upon 2 into under root of C upon
By
L. Okay, that is the formula. Fine. So I recommend or I suggest you to prepare further deep into the concepts. Cover all areas that will fetch you while you are going for interview. Okay. Any questions from you, ma'am?
सर जो भी वहाँ पे उसके लिए क्या नाम है इंटरव्यू में डेमो क्लासेस के लिए मतलब क्या कौन सा टॉपिक प्रिपेयर करना सही होगा कंट्रोल
So your
सिस्टम
question
में?
is in the interview they will ask you to explain one topic.
वन टॉपिक ऑन द बोर्ड मतलब वो
Yeah,
बोलते
there
हैं
are two chances. They may give the topic or they may ask you to choose your own favorite topic.
यस सर.
If they give you topic, we do not have choice, we have to follow that. If they ask you to choose a topic, you take a simple topic. Okay, that topic must complete within 10 to 15 minutes. And before you start the topic, it is mandatory to explain why we are studying that topic. And at the end of the topic, what we are going to get. Introduction must be there and conclusion also must be there. While explaining that topic, please keep in mind that you are explaining to students, not to the interview panel. You must explain in deep from basics. That is very important. Okay. Any topic your interest you can choose.
Sir, you suggest any something topic?
So I suggest you to take a steady state error topic which can be completed within 10 minutes. At least basic concept will be completed in 10 minutes.
Sir, or we can to the second order pole जो भी different poles होते हैं वो मतलब under damped, over damped, can we choose that topic?
If you choose that topic, first of all you have to explain what is damping. For that you have to take a system, get its transfer function, vary the resistance value if you take a series RLC network, get different dampings. Again, in damping we have four types. Undamping, where damping ratio is equal to 0. Yes.
Yes, sir.
And underdamped 0 to 1, more than 0, less than 1. Critically damped, damping ratio equal to 1. Overdamped, damping ratio greater than 1. So it will take some time. Okay. So take a simple topic, and that topic you must relate with the practical approach. Steady state error, if you take, you can give an example. There is one rocket moving. See, we want to blast that rocket. That rocket belongs to enemies. We want to blast that rocket. So we want to send some missile onto that. So we must design in such a way that it must reach to that rocket and our missile is going to blast that rocket. Steady state error must be equal to 0. In that way, we have to design. Or one more simple example you can take. There is a robot which is doing some operation for a patient. We must design in such a way that the steady state error of that robot should be equal to 0. Otherwise, if there is some error, even a small error also can make the patient's health very ill. Yes.
Yes.
So take some practical example also while explaining the topic. So in such a way, to see, the interview panel must find the enthusiasm while you are explaining the topic to them. And you always please think that you are explaining to the students, not to the interview panel. Okay, that is required.